Hi everybody, this lesson is titled 1.1c, Sample Spaces, Outcomes, and Probabilities. Let me give you a couple definitions to start here. Tree diagram. Tree diagram shows all possible outcomes of an event in an organized way. I forgot the E, organized way. There we go. Okay, so it's a way to organize a lot of information in any event. Okay, sample space. Sample space is a set of all possible outcomes of an experiment or an event. Okay, so with those two definitions, we're going to go ahead and start on some sample questions here. It says for numbers 1 through 3, use a tree diagram to answer the following questions. Write all fractional answers in simplest form. Number 1, in your closet, you choose from a red shirt and a blue shirt, and you choose from jeans, shorts, and sweatpants. How many different outfit combinations can you make? Okay, so use a tree diagram is the first thing I want to kind of re-emphasize there. And notice we've got shirts, two choices, a red one and a blue one. And then for our pants, we've got three choices, jeans, shorts, and sweats. Okay, so it doesn't matter if you start with the shirts or if you start with the pants. I usually just start with the first thing that they gave me. Okay, and a tree diagram can go down or it can go across your paper to the right. I should go that way. Okay, it's opposite. Okay, so I'm going to go ahead and I'm going to go red shirt or blue shirt. Okay, so starting right here, we've got two options, red shirt and blue shirt. Okay, then from red shirt and blue shirt, we've got three different pant choices. We could do a red shirt with jeans. We could do the red shirt with shorts. We could do the red shirt with sweats. Same thing with the blue shirt. We've got three options for pants. Blue shirt with jeans, blue shirt with shorts, blue shirt with sweats. Okay, so that is a tree diagram, okay, showing the situation. Okay, so it says use a tree diagram to find out how many different outfit combinations can you make. Okay, do you see that there's a red shirt jeans, that's 1, a red shirt shorts, that's 2, a red shirt sweats, that's 3, blue shirt jeans, 4, blue shirt shorts, 5, blue shirt sweats, 6. Okay, so there are 6 outfit combinations. Okay, letter A, there's the question. How many outcomes are in the sample space? Well, we just answered that. There are 6. List the outcomes. Okay, listing the outcomes. We just spoke them a couple of times. Okay, when we list outcomes, we use these little curly braces, not parentheses, not brackets. They're these curly little, they call them braces. Okay, so we're going to do a red shirt, jeans, red shirt, shorts, red shirt, sweats, blue shirt, jeans, blue shirt, I'm running out of space, so I just came down here, blue shirt, shorts, and blue shirt, sweats. And then I'm going to close off a brace. Okay, it doesn't have to look perfect. It's just a squiggly looking parenthesis type thing. Those squiggly parentheses means I'm a set. Okay, so you need to have those around when you list out a set. Okay, the outcomes is the same thing as a sample space. It's listing out what exactly is in that space. Okay, letter C. What is the probability that you would be wearing shorts? Okay, remember, probability from the last couple of lessons means it's how many times you would have shorts on over all of the possibilities. Okay, so looking at either my tree diagram or my list, how many times do you see shorts? Okay, I see a red shirt with shorts and a blue shirt with shorts. I see two options out of 6 options. Okay, so probability of shorts. It's always nice to have formal notation, a capital P with what you're finding. 2 chances out of 6. Okay, and notice back up in the directions, write all fractional answers in simplest form. Okay, so we better reduce that down to the 1/3 equivalent. Okay, I want you to pause me for a moment and I want you to see if you can figure out what the probability of a blue shirt is. So pause me for a moment, try that, and click me back on to see if you're right. Okay, probability of blue shirt. So blue shirts, you can either look here in the list or you can look here in the tree diagram. I see 3 different blue shirt with jeans, blue shirt with shorts, blue shirt with sweats. I see 3 different options that contain a blue shirt out of that 6 total outcomes. Okay, and again, make sure you're reducing it to simplest form, 1/2. Okay, any questions on that one? All right, number 2. You flip a coin 3 times. How many combinations are possible? Let's scooch that up. All right, so perhaps you want to pause me for a moment and try it on your own. Can you make a tree diagram with the flipping of a coin 3 different times? Okay, if not, no worries. I'm going to do it now. So you've already paused me and now you're looking back at me. Okay, so again, you can either do it from left to right, like I did this one up here, or you can do it from top to bottom. There's not really enough space to go top to bottom in this little space, so I'm going to do it left to right. Okay, so if I start here, my first flip number 1, I'm either going to get a heads or a tails. I'm either going to get a heads or a tails if I flip a coin. Okay, now my flip number 2, this is going to be flip number 2. I'm either going to have heads with a new heads or heads with a new tails. Down here, I'm going to have tails with a heads and tails with a tails. Okay, so that's my sample space of 2 flips. Okay, now let me change to purple here so it kind of sticks out a little bit better. So from this HH, I'm going to have 2 options. From this HT, I'm going to have 2 more options. From this TH, I'm going to have 2 options. And from that TT, I'm going to have 2 options. Okay, so HH with a new H. HH with a new third flip of a T. HT with a new flip of an H. HT with a new flip of a T. TH, H. TH, T. TTH and TTT. Okay, so you could probably come up with all those possibilities, but this is an organized way to keep track so you're not missing anything. Okay, so let's answer some questions. Okay, so it says how many combinations are possible? How many outcomes are in the sample? Same question. Okay, same question. Do you see that we've got 1, 2, 3, 4, 5, 6, 7, 8. We have 8 outcomes in this sample space. Okay, I'd like you to pause. I was going to say turn off your camera, but just to pause me. And I want you to try to answer B and C on your own. B, what is the probability of getting 3 tails? C, what is the probability of exactly 2 tails? Okay, so give that a shot on your own and then click me back on once you have an answer. Okay, probability of TTT. So this is called probability notation. Okay, I want to be very official in how I'm going to write my answer. How many TTTs do you see in the sample space? I see 1. And then how many total options are there in the sample space? There are 8. Can you reduce 1 8? Nope, it's already reduced. Okay, let's try letter C. Probability of exactly 2 tails. Probability exactly 2 tails. Okay, looking up here, nope, that's an HHH. It doesn't have 2 T's in it. Okay, I see, let me mark a little green mark by them. 2 T's, I see exactly 2 T's here, exactly 2 T's here, and exactly 2 T's here. All the others have something else, have no T's or 3 T's, okay, or 1 T. All right, so do you see 3 dots? There are 3 out of the 8. Okay, moving on to the next question, number 3. Okay, it says a deli prepares sandwiches with 1 type of bread, white or wheat, 1 type of meat, ham, turkey, or chicken, and then let me see what other color I have here, and then 1 type of cheese, cheddar or Swiss. How many combinations are possible? Okay, let me start with, okay, again, it doesn't matter. If you start with your bread, if you start with your meats, if you start with your cheese, does not matter. Okay, I usually just start with the first thing that they gave me. So I'm going to start with bread. Okay, I'm going to start with, since they both start with W, white and wheat, I'm going to have to write out white and wheat. Okay, now coming off the white, ham, turkey, chicken. I'm going to use an H for ham. I'm going to use a T for turkey, and I'm going to use a C for chicken, just for a shortcut. So ham, turkey, chicken. Off the wheat bread, same thing, ham, turkey, chicken. Okay, from each of those greens, Now comes a cheddar or Swiss. Okay, now I have to be careful because this cheddar starts with a C, and I already have a C for chicken. Okay, so what if I used a CH for cheddar? Yes, this is a CH also, but I said I'm going to use a C for this one. Okay, and then we'll use an S for Swiss because we haven't used an S yet. Okay, so off of the 3 of these, I'm going to have 2 marks coming off of each. Okay, and then coming off of these 3, I'm going to have 2 marks coming off of each. Okay, and I've got my CH and my S, CH and 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 S. Okay, a little bit tight in there. Okay, now it's really important to understand in the coin problem, I carried white, wheat, and I carried all these meats with the answers down here. So it's important to understand the CH means white bread with ham and cheddar. White bread with turkey and cheddar. Oh, and cheddar there, okay? So just make sure that you're able to read that. Okay, so how many outcomes you count? You don't count them all. You count the end here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm counting 12 outcomes. Okay, so again, pause and try to find the probability of ham and try to find then the probability of Swiss. Click me back on in a moment and we'll make sure you're all correct. All right, probability of ham. Well, I see 2 things here with ham. I see 2 things here with ham. And I see that would be it. So there are 4 sandwiches with ham on it out of 12 total 12 total sandwich possibilities. Okay, let's make sure we reduce this to simplest form, 1/3. Okay, now the probability of Swiss. Okay, the probability of Swiss, I see a Swiss here. That would be white ham Swiss, white turkey Swiss, white chicken Swiss. Okay, so I see 6 different sandwiches with Swiss cheese out of the 12 total sandwiches. Reduces down to 1/2. Okay, all right, so that's how you use a tree diagram to find out some probabilities and what's in a sample space. Now there's a shortcut. There's a shortcut called the fundamental counting principle. Okay, because sometimes I get a little lazy, I'm going to call that a FCP. That is nothing official mathematically. That's just Noonan trying to save some time. Okay, fundamental counting principle. Okay, so this is a formula. Let me give you the definition. A formula used to find the number of outcomes in several independent events. If one event has M outcomes and another has N outcomes, that looks like outcomes, N outcomes, comma, then M times N, that little dot means times, is the total possible outcomes of the event together. All right, the super cool thing about this You do not want to be doing a tree diagram when this gets any bigger than this, right? 12, that's pretty crunched and a lot going on. Okay, so this shortcut is helpful to find out how many outcomes or how many are in the sample space. What it's not useful in finding is what is in the sample space, listing the sample space. Okay, so let's look at number 4 here. It says use the fundamental counting principle to answer the following questions. Write all fractional answers in simplest form. Okay, remember the last questions we did focused on a tree diagram. Well, this time we're asked to use the fundamental counting principle. So number 4, you are trying to decide what to wear to the school dance. You know you want to wear jeans but are unsure of the shirt and shoes. If you are deciding between 16 shirts and 3 pairs of shoes, and if you try on all combinations for your friend to help you decide, how many would she see? Show work that justifies your answer. Okay, are we cool that everybody's got jeans on? Everybody's got jeans on. It's just, what are you going to wear with the jeans? What kind of shirt you wearing with the jeans? What kind of shoes you wearing with the jeans? So really, we're looking at shirts and shoes. Shirts and shoes, okay? Now, the fundamental counting principle formula says you multiply how many shirts there are, 16. There are M outcomes of shirts, 16 outcomes of shirts, times, and then you take the N outcomes of shoes, 3 pairs of shoes. So 16 times 3, 48 possible outcomes. Okay? You could say 48 possible outfits if you wanted to. Okay? All right. Pause me and you try number 5. Catch you in a quick moment. Okay, Grace loves to eat salad. How many salads can she put together if she can pick out one type of lettuce from 2 choices? So we've got 2 kinds of lettuce. We've got vegetables from 4 choices, and we've got dressing from 7 choices. Oops, I gotta push that up. Sorry, guys. Okay, so I've got lettuce, vegetables, and dressing. All right, well, I've just got to find out how many lettuce choices I have. 2. How many vegetable choices I have. 4. How many dressing choices I have. 7. Multiply all those together. 56 different salads can be created. All righty? All right. Last page. All right, California used to issue license plate consisting of 2 letters followed by 3 numbers. There are 26 letters and 10 digits, and the letters and digits may be repeated. How many possible license plates could be issued with 2 letters followed by 3 numbers? Show your work that justifies your answer. Okay, so letters. How many letters in the alphabet? They tell you 26, in case you didn't know, okay? And then they tell you that we've got numbers, 10 different numbers to choose from. Okay, so is everybody good with, think about this. If you wanted to pause and try and then click me out in a minute, go for it, okay? Okay, check this out. 2 letters, and 3 numbers, number. Okay, so there are 26 options for a letter, 26 options for another letter, 10 options for a digit, 10 options for another digit, and another 10. Okay, when you multiply all this together, you get 676,000 possible license plates can be made. Okay, any questions on that, guys? If so, we'll catch you in class when we discuss this, okay? Okay, I think for the sake of time and just staying within standards that we need to, I think I'm going to skip number 7. If you would like to try number 7 and look at the answer to number 7, I have that posted in Google Classroom, and I'm happy to take questions on it when we discuss this, when we're in class together and we're discussing 1.1c. Okay, but that's it for now. Bye-bye, guys.